this, Ted? Good afternoon, NOTACON. I'm here today to introduce Steve Lazenby. Steve is a German marine biologist specializing in planktology. He received a habilitation in the Vigna Legandi in Marine and Fisheries Biology from the University of Kiel. His PhD work in the metabolism and behavior of krill, for which he participated in an expedition to Antarctica, won him the Heinz Meyer-Leibniz Prize in 1979. His work was honored by the Heisenberg Fellowship and Bioscience Prize of the Volkswagen Foundation. Now it's my pleasure to introduce to you Steve Lazenby.
Thank you. Well, how do I follow up that? I think maybe I'm at the wrong conference then. Okay. So what I'm going to talk about is, most of what I'm going to talk about is stuff that I encounter in my day-to-day life and mainly my workplace. So how I got where I am, how we got to some of the messes and the problems that we have now. This lovely, interesting place right now where we are with formats and file conversion and everything, where it is almost hell. I deal with this stuff on a daily basis, and there is no rules, there is no real standards, and it's a nightmare. Where we're going to hopefully be going, we'll hopefully sort out some things, and the more people that actually pay attention to this stuff will get rid of a lot of the bugs and roadblocks that we currently have. I'm going to be talking about some of the hacks and fun little things that I have been doing at work just to kind of get around these kind of obstacles and some other ones. So I just found this when I was at my parents' at Easter. I've been playing around with TV since I was as young as I can remember. I started working at a community cable channel when I was 13. I just volunteered. By the time I was 16, it got sold a couple times, so there was no tech support. There was no one to help us out when things go wrong. And I've always been a techie, so I just naturally started figuring things out. I'd be crawling behind the racks while we were on air, and when things didn't work, just start fiddling with things. And by the time I was 16 and I was there, I had rebuilt 2 of their control rooms, 2 of their mobiles, and later went on to college and kind of did more of that, did audio with bands, always been kind of involved in the tech side. They always kind of all intermingle for me. Went to college, wasted my money at the Toronto Film School. For those of you who don't know, private college, a company that's currently being sued by about 1/10 of their students for their lovely education. Went to there for digital film and television production, then didn't end up learning anything about television, and then graduated, and then they started employing me. They hired me to maintain all their television equipment in their control room. That's a bit dark. One of my main pet peeves when it comes into any kind of working environment is how ergonomically painful it is to work in these kind of places. This is kind of part of the original setup. Monitors were all over the place. Within the first 6 months of working there, we were having students come in with medical notes from their chiropractors because they were having neck pains and stuff, having to do things like that. So this was a facility I didn't have the pleasure of building, but I was there and redid all of the stuff for the first couple of years. Right now, this is currently being torn apart with sledgehammers. They're moving out of there, and the students get the joy of actually demoing the school. I currently work at another college in Toronto. I'm not going to say the name. I've shot myself in the foot already. I used to blog about my industry. A lot of my issues and concerns about the industry, and there's not too many major employers, and I'm not about to get in trouble with my current college for saying things, because I'm going to have some examples from there. This is just in the process shot from in the middle of the summer. This room is now finished and in use. This is just a small 4-camera newsroom that we built for the journalism department. This is what I spent most of my summer on. This is the old TV control room for our main studio for the television production students. Is there any way we can get this a bit brighter on the projector, or is that the lights? Thanks. As you can see, lots of fun CRT monitors. Once again, this was an ergonomic nightmare. On the left-hand side, you'll see the wings of the desk actually turn away from the monitors. So you had people working on either side looking in the absolute wrong direction of where they were supposed to be. So we ripped that out and rearranged the room. We got a lot more square footage. And this is what we have. I don't know if I have a wide shot. We actually went to a system. Those are two 52-inch LCD monitors. And then above those are two 26-inch broadcast grade. So we have those for monitoring color and what the actual shots are going to be. So where did we begin with video? Why am I here complaining? I hear it every day, but if you're not involved in the video industry or if you're not involved with new media and a lot of this stuff, it may seem a bit out of place. Analog video, we have two fields. We have two fields for every frame. We have an odd frame and we have an interlaced frame. Then the odd field and then an interlaced field, and then they go together to form a full frame. I won't get into the technical reasons why they did exactly that, but it was what they had to do to get the television picture out over the air to everyone because of the equipment at the time. And we were stuck with it. So I'm not sure how many of you guys are familiar with electronics and electrical stuff, but everything comes back to about timing and frequency and how it all relates to each other. In North America, we have 120 volt power, 60 hertz, so it's switching polarity 60 times a second. And if you've ever heard audio buzzing over your speakers or something, you'll hear the 60 hertz. So when it came time, to figure out how they were going to put this together and send it out magically, they were able to reference the sync pulse, or the timing of the power. So 60 hertz. We originally had 30 frames per second. Each pulse was one field. So that's how we have 30 divided by 60. Pretty simple math, just divide it by 2. Then they came along and decided they wanted to put color into it. Well, all the channels and all the frequency spectrum was already set up. So they couldn't go just changing around everything. And they'd already had nightmares before where they had introduced proprietary television systems that weren't upgradable. They wanted to upgrade to color, but there would have been a huge backlash if they had to make everyone with black and white TVs get rid of them because they were going to be upgrading. Kind of a bit similar to now what they're doing with HD. So what they did is to cram that extra color information, they went from 30 to 2997 frames per second. A bit of a pain in the ass, but there's some voodoo in there to make it work. And the big thing with this in the broadcast industry is now it's not the same as what's coming in on the power. So no matter where you plug in, it's going to be alternating back and forth at 60 hertz. We need 2997. So this is where part of the reason why syncing came in, and is kind of for a lot of people that just do single camera production, they never have to worry about sync. Analogy I use with students all the time is, say we have two basic camcorders. They both have motors in them. What are the odds? Both these motors were probably made in Japan somewhere. They probably cost like 10 cents. What are the odds that the motor on the left is going to turn at the exact same speed as the one on the right? I bought two motors about a week ago when I was working on a robotics project, hooked them up to the exact same power supply, measured them. The one was turning 10 RPM faster than the one on the left. So what does this, in a field production kind of situation, that makes sense. You'll have your audio recorder, or your film recorder, or your video camera, and ideally you want them all to move in sync so that when you go to the editing process, you can line up your audio track and your video track and have something desirable come out. We saw some videos last night where the audio and the video started to lag. When you're doing short stuff, you can kind of get away with it, but if you're doing things like features and anything that gets longer, if it's a little bit out of sync at the beginning, it's just going to get worse. Another way that people like to assume that if I give you two video cameras or two audio recorders or anything, that they're naturally going to be in sync. Same with digital audio recorders. Why would they be in sync? They assume sync is some sort of gravitational thing, like it's It's just there. But for them to get a sync, for them to have sync, there needs to be an internal clock. The internal clock could be messed up by temperature, voltage changes, any of that stuff. So when we get into doing video, especially HD stuff, we have a whole pile of different sync rates. Back when we have the analog video, it's one standard sync pulse in North America for all of our stuff. With HD, there's a whole bunch of stuff. And then if you're out on location shooting, you'll have your video camera recording at one frame rate, and then you'll have your audio recorder moving at a completely different one. The way I like to explain that is put two drummers in a room. We want those drummers to play the exact same piece of music. We give them a metronome. They can follow that metronome and pretty well play in sync, and if they're any decent. But now let's say change up their music. We'll pull the metronome out of there, and we want Ringo to play at 4/4, and we want Animal to play at 6/8, and we're going to hope that we can record that and then put them in some sort of sync so they hit enough of the beats at the same time that it sounds good. Well, the odds of that happening aren't very good. You're going to have to compensate one thing to fit the other. You'll see with this stuff, if we're doing video and audio editing, well, we won't touch the video because that takes a lot of time and computer energy. We would take the audio and stretch it or squish it or cut bits of it out to make it fit. I've seen students edit feature films where they're manually having to sync up every 5 seconds because it's drifting. So we're in this lovely mess of HD, but what are the things that we had to get to use before here? I kind of just did it out in columns. Well, we had the lovely VHS world, VHS, and then they tried to make it compact for cameras, and then they decided, okay, let's make it a little bit better. They put more color information on it. We had Super VHS. They decided, let's make it HD. So back in the 90s, they were messing around and made analog HD with WVHS. Then they tried making digital VHS. And then they decided, let's put HD digital onto VHS. And some Fox stations still use it. They call it D9, but they've finally given up on VHS. VHS is dead. The beta side, it kind of was in the consumer market for a while, and then it died after VHS beat its ass into the ground. But they had Betamax, Super Betamax, and various others. But Betacam is where it really took off for the broadcast industry. Because before Betamax, there was still a lot of people using open reel recorders or 3/4-inch tapes. They were big, they were bulky. The small tapes could only hold 20 minutes, and then the bigger ones were huge, but they were clunky. Betamax was smaller. It's the same size as the Betamax tapes, the same half-inch tape that you would have in VHS tapes, something a lot more smaller and transportable. They upgraded that, Beta SP, more color, better information on it. Digital Betacam, Betacam SX, because digital Betacam was too expensive for anyone. Then they decided to make an MPEG one and put IMX on it. Then they have a couple that are HD. So that format is still kind of out there. On the other side, we had a bit of a consumer, a lot of the small consumer cameras were 8mm, then they were high 8, then we had digital 8 come around. Well, the format they recorded on digital 8 is the same information that's on there is on a mini DV tape. They just changed what kind of tape it goes onto. Mini DV, that whole revolution when it changed, when Final Cut came out and got to a point where it was usable and friendly, and Mini DV came out, and they all seemed to work, everyone thought editing video and all that was easy. Because before that, you're going to have big edit suites. You're going to be taking large amount of times to render out your video files and everything. But DV came along, you plug your camera into the computer with one FireWire, it works, it looks pretty decent. It's not as good as broadcast, which would be Betacam SP, or one of those formats, but it's pretty damn good. You don't have the generation loss when you're dubbing tapes on any of the other analog formats. That kind of came together with a lot of the main companies, Sony, JVC, even Canon. They came together and made this format. And then after a while, they decided, we're going to do our own thing. So then you have all these bastard variants. DV Cam was what Sony decided to do. It's mostly the same, but then a little bit different and not compatible with anything else. Sony seems to be very good at that. If anyone's familiar with Sony, then they'll have a lot of fun stories to say. DVC Pro is what Panasonic decided. They were like, they use a larger cassette for a lot of their stuff and wanted to put more on it. DVC Pro 50, they decided, we're just going to move the tape at a different speed and put twice as much content on there, but that's still not HD. HDV is pretty well what I'm thinking is going to be the last you see on those tapes. They take the tape that's moving at the same speed as mini DV and decide that they're going to cram more information on it while it's moving at the same speed. So they actually take less bandwidth than they use on mini DV and try to cram more information. So that just means that they're compressing that a lot more to fit HD onto a mini DV tape. This is just all the tape formats. Getting into, with HD, we have a lot of file-based recording methods. Sony is pretty well good at coming up with formats, but not so well supporting them. All those Betacam formats underneath SP, all the tapes are the same, they just record differently and they're not compatible with each other. Those are still out there. They record onto optical discs. The HD cam variants, is that on my next slide? The HD cam variants record on S/S cards, which are Express Card 34 slots, a lot faster than the PCMCIA slots. But their 4 gig and 8 gig cards are about $1,000 each. Fine if you're a huge company. But when before, a tape would cost $20, $30, you throw it in the camera, you shoot, you leave it on a shelf. You can't really do that with a $1,000 card. They have now just come out with adapters, third-party stuff that lets you record on SD cards and things like that. Sony has some HD stuff that records on memory stick. The optical disc stuff. They have some hard drive-based stuff now too. Panasonic has P2 cards, which are basically PCMCIA cards. The same kind of thing with that Sony came out with the SBS cards. The handy thing is you shoot on them, you can plop them right in your laptop, and you're good to go editing. But as again with those, they record it in a different way on there, and the cards are still about $1,000 for an 8 or a 16 gig card because they're super fast, but not really convenient. They take away so much of the hassle with tape, but at a cost point where it's still pretty expensive to it. Computer graphics and video have really been separate most of their lives. Computer graphics could be any resolution, doesn't really matter as long as we can produce them on the computer and we have something to display, we're happy. Television, because we have to fit it through that narrow pipe and get it out and broadcast it over the air and over cable, had to be a specific set of standards. So typically 720 by 486. Some of those lines are lost around the picture that you don't see. We have that 5994 sync reference, so that's 5994 for every field, which cut that in half. That's our 2997 frame rate that we have. And we have our 4:3 aspect ratio. Everything's the same across the board. So everything got stretched on my thing. Okay. So we have our 4:3 picture on a 4:3 screen. Everything seems happy. I'm sure you guys have all seen TV lately. CNN and all the news networks are horrible for messing with aspect ratios, and it drives me nuts, but there's not much I can do with it. Simplest thing, we have a 16:9 on a 16:9 screen. Here's where it starts to get a bit of a pain in the ass. Everyone pretty well puts out 16:9 now, and if you watch it on a 4:3 TV, they're either chopping the sides, cropping it, or they're putting the letter boxes on the top and bottom. But when they have 16:9 stuff, we're a 16:9 facility, and students bring in stuff from all over the place. They bring it in from YouTube, they bring it in from VHS, DVD, and it's all over the place. So we end up having things where it gets double pumped. So it's a 16:9 and it gets crammed down. They say the TV adds 10 pounds. You see a lot of the sports shows and all that stuff. When they're bringing in their footage, it's all squished and all over the place. Well, in Canada, we have, everything is predominantly 1080i for broadcast, so it's a bit simpler. Down here, it's a mix between 1080i and 70p. The I stands for interlaced, and the P stands for progressive, which basically means they send the full frame in the right order and not hopping back and forth like they do with interlaced. It gets a bit confusing when it comes to the letters because they'll put the letters at the end of any of the numbers. It's really hard to list a specific 3 or 4 standards because any of the editing programs, any of the stuff you work on can produce almost anything. They can create formats that aren't even playable on TVs. I had a student come in the other day with something that wouldn't play because it was 600 by 300 and 80 frames per second. I don't know where they come up with this stuff. Probably because they're doing drugs at the school at night. I don't know. So you see 1080i, 720p, 24p. That's the kind of, you'll really see the broadcast stuff is really in the 1080i to 720p range, because they're still limited on what they can shove down that pipe. 1080p, they can't really shove down that pipe yet, because a 1080i stream is 1.45 gigabits per second. So 1080p is double that. It's a 3 gigabit stream. And that's still a bit, that's how we transport it around between all of our equipment. And then we have 3D, which is, from what I've read, is basically the 1080i, but they're basically using one frame for each side and swapping it back and forth. So before they even get those, they haven't even really rolled out HD and gotten rid of all the analog stuff yet, and all of a sudden they want to spit out more bandwidth. I don't see that happening on satellite. I really see that happening, when everyone has fiber in their homes. So back in the analog world, we basically have one set of stuff. You export your stuff out of your program, you put it on a tape. It's pretty well the same thing. Now, when it comes to file formats, pick and choose. This is just some of the more basic ones. 640 by 360, I've only listed the 16 by 9 ones here, but the 640 by 360 is 16 by 9, but it's basically chopped in half the 1920. That's what YouTube seems to like a lot, if you want to put your stuff on HD. Better than the 320 by 240, but it's crammed down. So 1280, the 720 stuff is, it's 720 lines up and it's 1280 across. But with the 720p stuff, predominantly they do it progressive. So less information so they can cram it in there. But they mix it all up, because sometimes you'll see the P at the end of the 720p or 1080i. Sometimes they'll decide to put it on how many frames it has per second. So any of the stuff that they do, they try to make it look like film, because film is 24 frames per second. So you could shoot our HD stuff in 24 frames per second and get more of that film look. In Europe, their power is 50 hertz, so everything is cut in half and it's 25. They had enough space to put color on, because they use a completely different system, that they didn't have to re-engineer all their infrastructure for that. We have 30. We have some of the stuff will do 50 and 60. You'll see the numbers completely mixed up all over the place. Sometimes you'll see 60i, so they're talking about the 60 fields interlaced per second, or you'll see 1080i. You kind of have to read back into the specs and figure it out. On especially on consumer stuff, they'll use whatever number is the biggest. Whatever number looks bigger, because, this is 1920. Or it's whatever they can make it to make it more sellable. But once we get into the broadcast thing, we have this whole other thing when it comes back into that sync thing. Because we have all our broadcast cameras. They're still scanning those lines. In some sort of digital way, they need to send the data in a logical way. Well, in our analog world, they're all getting, all the cameras in the studio, they're all being fed the pulse at the same rate. So they're all scanning at the same rate. So if we want to cut between one camera and go to another one, it's just switching it, and the beams are in the same spot. We get a nice clean switch. In a facility where you're editing, all the computers would be getting the same sync pulse. So they're doing all their work at a constant rate. From my experience, computers are horrible at keeping time. The job of a computer is to take its information and think as fast as possible and spit it out, not keep a constant time. So every standalone computer I've ever had that's not on the network and doesn't talk to anything would drift. And some of the broadcast computers I've worked on in the past would drift upwards of 10 seconds a day. And when you need these computers to talk together in a broadcast world and be in sync, that's pretty painful. We've gotten over a lot of that stuff basically and cheaply with network time protocol, which just spits it out over across the Ethernet. But we still have issues around that because it's not moving at the same thing. It's not moving at the same speed and latency involved in that. What was I going to say? I'm going to get into some of the, I'm going to jump a bit to some of the things I get to mess around with at work and just try and make things fit. So they came out with this lovely box that takes 720p in and spits it out in HD, so you can put it on your cable at home and tune in your computer on your HD TVs. Well, it works great, but it's doing a lot of stuff. Typically before this, we would need a whole bunch of professional boxes that were upwards of 5 to 10 grand. They do it for 500. This box is a hot plate. I ended up ripping it out of its case and shoving it in this chassis so that we could get enough heat. It was passively cooled before with no vents, and after having it on for 5 minutes and not even active, you could not touch it. They've later come out with one that now has external video inputs. This one only had VGA, and the audio came across USB. And this was a rush project. They needed it up on campus, so I had to take this and try and make it work. So we have it coming out of a signage PC. It spits it out 1280, or 720 by 1280. I have it going to a component switch so I can switch between our live control room. Then it goes to the modulator and out to the cable system. Well, when we want to go live from there, I have to switch over the component switch. The audio has to go back to the signage PC, go through 2 or 3 programs to restream it, and then send it back out across. It's not perfect, but this is what we did in a pinch to get it working. You can ignore where it says where I work on there. That is what I thought I'd throw that in there. When I was putting up all these, this one kind of got dropped, and that's what an LCD TV looks like when there's a small crack at the bottom, and it just starts to work all the way across the screen as it heats up. Not fixable and something to get in trouble over. I'm going to quickly go through this. Another thing, I deal with students all the time, so they expect everything to work, and they expect it to work exactly how they expect it. When it comes to files, we have our file format, our container, and we have our codec, so how we shove the files inside of it. Just because it's a QuickTime movie doesn't mean it's encoded in any specific format. I used to use the analogy that it was, you take your information is your file, it's a piece of paper, you rip it up and you shove it in a box, that's what comes across on the other side, you open it up and you try and put it back together. With a lot of the stuff that the students do, I end up using the analogy that it's like they're throwing up in a garbage can, you're moving it across to the hall, and then trying to reassemble it again. They're able to make formats that don't technically exist sometimes when they're rendering out files out of editing programs. Broadcast equipment is pretty specific. It only wants to play certain kind of file formats because it knows it will work. And that is something that is really hard for people to get across and understand. I'm just going to keep jumping a bit. One of the side video projects at the Hack Lab TO in Toronto is we rigged up a small cable car. Those two pieces of aircraft cable run from the front to the back of the space. And the idea is to send power over them to drive this and also send the data to pulse it. There's a servo connected to that. We've run it while it's wired up, but we've yet to get it all fully wireless. I like messing around with video stuff. It's a bit of addiction. In the summer, I had to build some teleprompters, because teleprompters are about $4,000 a head. All they are is an LCD. And they flip the video and spit it up. So I ended up having to do a couple hacks. Last minute thing, because I had LCDs that were dead with backlights and no money to replace them. I have video going into VLC, flipping the video, spitting it out, going through my camera system, going into that box, which drives an LCD. I got a whole pile of LCDs free from our IT department because they miscounted at ones in our department. And they're like, here's your 20 LCDs. Okay. So I redid all the ones in the front of there. I built this prompter system from scratch. Those are all the parts I painted up. Those brackets with all the holes are actually shelf brackets I cut up and did. So I was able to pull across prompters for about $1,000, less than $1,000 each with the glass and the monitor and all the adapters. I'll skip that. I'm going to quickly jump through the last two. Broadcast software is all specific. 95% of it is all on PC, just because PCs are cheaper. That's mainly the reason behind it. A lot of them use old software. They don't talk to each other. And it's really kind of apparent in some of this. I have 3 pieces of software that all use databases for users, and none of them talk to each other. So I have to create about 1,000 users every semester, and most of them are the same ones. This is the system we went with. That's one Windows box that has 2 channels of clip store, 2 channels of CG, takes 8 video inputs. This is all HD, by the way, and then spits it out. And we had our headaches with this. Not because of the product. We found out later on, about 2 semesters in, we had a lemon. and it wasn't in their hardware, it was in the CPU. Because it runs Windows, but that just makes it a real huge pain, because when something crashes, this is a sync issue we were having because of the computer was messing up and sending something completely weird to the cards. I'm normally hopping around between many things. I ended up getting a health and safety issue on my office. I ended up doing a lot of late nights and things to get things done, and then at the end of the week or end of the month, everything just piles up. I'm horrible when it comes to time management and stuff, considering I'm already going over. For me, I love making stuff work that's not intended to work. I skipped out a bunch of things, but I have a whole pile of old equipment kicking around at work, and I have to use it to make things work with stuff we need now. Like I have digital, to get signals to digital and delay it all around. I go through multi-effects processors and things like that. And there's lots of areas for things like that to fit in and go together and to make things work, and especially in the software side. There's so many pieces of broadcast software and products out there that are just asking to be made or talk together, and just no one does. Probably a lot of it is, it's very much of an old boys club when it comes to a lot of this stuff, and not a lot of people are hopping in with new and exciting little projects. I think that's about it. Does anyone have any questions? I'm completely blind, so. Okay.
Tape formats.
Yep.
What about, I see a trend with all the, basically like the DVDs and all that type of technology. What's your view on that?
Well, with DVDs and all that, like Sony, like I was saying, Sony basically ramped that up and started doing video on really high definition discs. They put it in a case because they're so sensitive. But with DVDs, same like film, you're worrying about the actual material itself degrading. So for any kind of archiving stuff, you need to be really worried about that. For consumer stuff, it's whatever is cheaper to send out. So I see DVDs and all that being around until it's cheaper to send it over file. So will DVDs still be around once everyone has fiber in their homes? I would be hard pressed to see it. I see it'll probably be more centralized stuff where you rent and have your playlist on some computer somewhere. But DVDs and that kind of physical medium are really limited on how long they last. There's a lot of CDs even that won't play now because the way they put it all together with all the plastics and stuff like that start to degrade and start to fog up. But. Well, DVDs haven't even been out long enough to push their thing. They still have some that are pushing 10 years, but what about the Blu-ray stuff and that stuff, where they compact it all on, so compact, one fingerprint on it and it won't play. Really the only thing that's been out there that's an optical media to test for this is CDs, because they've been around and being tested from the late 70s. So we've gone from a CD, which is it's the same shape, and all we do is just start putting more and more and more data on it. There's a couple places where they have to upgrade that. One of the things where they're pushing at is instead of just having one video track on it, is they're actually looking at using two lasers on an angle and building a holographic track in there, kind of like a record path. And with that, you're looking at upwards of about 100 gigabytes. But you get back into that more eggs in the same basket. You're putting a lot of media on a small thing. One fingerprint on that device or one scratch, and not like a CD where it'll skip, it just won't play at all. But for archiving and stuff like that, or the odds that you're going to buy stuff for consumer media and still have it play in 20 years, that's pretty well up in the air, I think.
Now you mentioned, like with tape formats, you have the betas, and then they are incompatible with each other. Now with DVDs, they have this UDFS format, and it's like 1.1. Now they have 1.5 and then 2.0. And it's funny, Windows 95 doesn't support these newer formats, and as you go, and Windows XP can't even keep up with the formats. How do you think all these things are going to be reconciled? I mean, is there a point where people just say we can't do it anymore and that get lost? I mean, like films from the 1920s, we can still show. If we go 50 years in the future, what do you see there?
Well, our whole industry right now is based on what's being driven by the consumer. Do you think, I really don't believe that the consumer said, we need better HD TVs. The industry's decided to come out, well, we've saturated the market with TVs, the current technology, we can't really sell more. So it's the suppliers trying to create a demand for something else. So as long as you have suppliers that are trying to push out new formats and new content so that you have to buy new hardware, you'll always be having that battle. I haven't had any issues. I use Mac and I use XP, and I don't have any issues with going back and playing old stuff. I haven't used a standalone DVD player for any of my personal stuff in a couple of years, just because I'd used all digital home theater stuff.
Broadcasting, you were talking. I don't need. With broadcast. Pardon. Oh, okay, I got you. For broadcasting over airwaves, that's what radio frequency.
Yep.
And then as we're moving into digital cable, or what's the transport there, and is that going to be changing?
Well, the transmit over a physical wire will be RF. They're really pushing the limits of how much they can push over the wire with cable right now. They can do about the same with telephone cable right now, because it's direct point to point to the house. They have it's comparable to digital. They're trying to push. They do some HD over it, but that's a single point to point over a dedicated piece of copper. So they're able to pull that off. But until there's fiber, everything is going to be RF getting into the house. So, because even with DSL, there's a certain part of RF in there, how they modulate it and hide it over with the voice. So until we're all fiber, until all on demand, these standards are going to be a pain in the ass, because these are the standards we need to use to get them down those pipes.
And then once we go into something like fiber, we're looking more like a packet-based.
Yep.
Okay, like TCP/IP or.
Yep, because it's going to be more. It's going to be more and more streaming. Like a lot of
Right.
your your digital cable at home, you're not getting four digital channels down that. You're getting one data stream in, and it's just decoding it. So it's slowly moving more and more to that. But it's that balance of, is it more bandwidth conservative to send 12 channels to everybody, or to only send the specific ones to the specific people that need it? That's really, once you get a more complex network going between them, if they send only what they want to each place, they're able to monitor it, and they're able to charge more. Because if they're able to put a whole on-demand system and it's all file-based, you're going to be living on that. And that's kind of what they're hoping on. You're going to be hungry for that media. And kind of like how iTunes is for a lot of music, they're hoping to get the video area to that. Broadcasting is dying. People want things when they want it. People like broadcasting because it's free. But that's slowly gonna fade out. So.
Thank you.
Thank you very much.